Okay, in this section, we're going to talk about how to prove if-then proofs. If something, then something else. If this is true, well, what's true? And the answer is the givens. If something is true, then something else must be true. Well, that's what you want to prove. If this is true, then this other thing will be true. That is, given a set of conditions, given the givens, you have to prove something else is true. So, if somebody asks you to prove if this, then that. Well, the this, that's what you're given. And the that, that's what you must prove. If this is true, it must follow. It must be the case where that's true. Well, prove it. I don't believe you. Prove it. You mean if this is true, that must be true? I don't believe you. So, to convince me, you have to start with the given statements, and prove the conclusion. Okay, so for example, if two altitudes of a triangle are congruent, then the triangle is isosceles. If this is true, that is given that, we have to conclude the triangles are isosceles. So, let's write up. So, this is a section where we're going to prove things without even a diagram. We are going to be given a triangle. We have a triangle. Call it A, B, and C. And we're going to be given two altitudes. Given altitudes AD and what I'm about to define to be BE. Given two altitudes. Okay, and we're also given that the altitudes are equal. AD and BE are congruent. And we want to prove that the triangles is isosceles. Proves that triangle ABC is isosceles. I'm going to prove that it's isosceles. And remember that altitudes meet at right angles. So, this here is the problem. We wrote up the problem this time. It wasn't given to us. Sometimes in mathematics, you have to write up the problem. Do you notice something? Hey, look at this. The last 5 examples, when those altitudes were equal, the triangle was isosceles. Is that always true? I don't know. Let's prove it. So, statement and reasons. Whenever you notice a pattern in mathematics, try to prove it. Sometimes you find out it wasn't true after all. Statement 1, it's the givens. This. 1, the reason, it was given. You're given the givens. Number 2. So, like I've always said, let's try to know how we're going to proceed. In this triangle to the left, I see two triangles. This green one down, oops, that didn't work too well. Let me put that back. Okay, so we have this blue triangle down there. Let me attempt to use the green again. The green doesn't want to work, oh well. So, I'm going to have to use the blue again. We have this blue triangle over there. We have the solid blue and the dashed blue. And what I'm going to do is, in the lower corner, I'm going to draw both of them. This here is the solid blue one, maybe bigger than needed. A, B, and I said I was going to call that point E. A, B, and E. And point E is a right triangle. Is a right angle. And the dashed one, it also has a B, and up here, angle D is a right angle. Now, they both have AB in common. They both have AB in common. And we were told that AD and BE are equal. Well, in the right, and the hypotenuses are the ones with the X's, the AB. Well, in a triangle, in a right triangle, if the hypotenuses are congruent, and you have one leg being congruent, the triangles are congruent. These two triangles, triangle 1 and triangle 2, are congruent. So, what that tells us is this angle, which I'm calling 1, which is made up between the right angle and the hypotenuse, in triangle 1, the right angle and the hypotenuse, that's angle B. Well, those are equal. Big angle 1 and big angle 2 are equal. And that's just what we wanted to prove. So there's the sketch. Before you do these proofs, you should see what you want to do. You want to have an idea what you want to do. Okay. So, first thing you want to do is say, so let me put back those two triangles, maybe on a smaller scale. This is ABE, and E is a right angle, and then ABD, and angle D is the right angle. Okay, so AB is congruent to not triangle, but to just AB. AB is congruent to AB. The reason is the reflexive property. Okay, so AB and AB are equal. Angle E and angle D are right angles. The reason is altitudes meet the opposite sides at right angles. For example, the altitude at this B down here. You go to angle B and you go to the side opposite it. Maybe you hit here, that is, maybe you go from B to that point, or B to this point, or B to that point. But whatever point you pick, and there's only going to be one of them, it better be at a right angle. That is the definition of altitude. Okay, so that's why statement or reason number 3 is valid. So now we have the right angles. And we also said in the givens that AD and BE are equal. They're congruent. But now we have a right triangle, and the hypotenuses are both the same, and we have another leg the same. So by hypotenuse leg is congruent to hypotenuse leg, we can now say that triangle ABE is congruent to triangle BAD. The two triangles down here, them congruent. Okay. Now I'm going to say that angle EAC, this big angle here, is congruent to angle ABD, this big angle there. And the reason is that angle A, this angle A, it's made up with the side with the X on it and a side with no slashes. And angle B is the side with no slash, is made up with the side of no slashes and the angle with the X on it. That's why they correspond. Okay. Corresponding parts of congruent triangles are congruent. But that's the proof. I have this big angle down here and this big angle here, EAC, EA. Okay, the angle was called, angle A down here is EAB. That's a B. Sorry. Angle EAB, this big angle here, is congruent to ABD. ABD. That's this big angle here. But now, if you look at the one triangle, the one without the altitudes, we have that angle A and angle B are equal. I mean, I'll put E here so you can see angle EAC, and I'll even put D here so you can see ABD. But either way, those base angles are equal. So when you erase down here, then we'll finish writing it up. So first, once you write down the problem, because in these you're not even given a problem, once you write them down, you should think about your strategy and then write it up nicely. Number 6. Oh, okay, so we already have it. So number 6. Triangle ABC is an isosceles triangle. Reason? If two angles of a triangle are congruent, and if you want to write 2 or more angles, fine. If 2 angles of a triangle are congruent, then the triangle is an isosceles triangle. So the proof is done. I want to make another point. Something that we can add to ways of showing that a triangle is isosceles. Initially, we said that if 2 or more sides are equal, then it's isosceles. And then we said If you have two or more angles, then it's equal, congruent, then it's isosceles. Well, now we just learned something new. If the altitudes, if these two lines that I just drew, the ones that are in blue, if this length and that length are equal, it is an isosceles triangle. For the record, if the third ones are equal, if those three altitudes are the same, it is an equilateral triangle. And every equilateral triangle is isosceles. Why? Because if all three sides are equal, like in our first case, you can find two or more equal, so it is equilateral as well. If these three angles are equal, it is equilateral. But by definition, if two or more angles are equal, it is also isosceles. If the three altitudes are equal, it is equilateral. We can also say it is isosceles. Not, if you're isosceles, you are not necessarily equilateral. If only two sides are equal, then you're not equilateral. So here is yet the third way of showing that a triangle is isosceles. Let's try another problem. That we want to prove that the altitude to the base of an isosceles triangle bisects the vertex angle. That is, if you have an isosceles triangle, this altitude bisects this angle. It bisects it. Same. Okay, so let's write this up. If the altitude, well, let's think about that. Okay. Let me not write it as an if then. The altitude of an isosceles triangle bisects the vertex angle. That's the vertex up there. The altitude bisects it. Okay. So what are we given? We are given triangle ABC. And we can write that. You're given triangle ABC. Let's call this D. You are given altitude CD. You are given altitude CD. You are given that AC in length is congruent to BC in length. Two sides are equal. And that's it. You're given the triangle, you're given the altitude, and you're given that it is an isosceles triangle. And what we want to prove is not AD, but CD bisects angle C. Angle C is the big one. Okay. So, it's screaming that there are two triangles as well as the big one. There's the left-hand triangle, ADC, and the triangle BDC, the ones I named 1 and 2. And we have immediately that these two triangles are isosceles because they're both right angles, they're both right triangles. The hypotenuses are given to be equal, and they have a common leg, CD. So by hypotenuse leg theorem, triangle 1 and triangle 2 are congruent. And angle 1 is made up of 1 slash and x slash. And angle 2 is also made up of 1 slash and x slash. Therefore, they are corresponding angles. Angle 1 and angle 2 are equal. And now that we know how we're going to do it, how we're going to proceed, we write it up. So, we have what they gave us, call it the givens. And the reason is it was given. And now we want to say is, so in particular, in the givens, we're saying that AC and BC are congruent. The side that has 1 slash are common. Now we're going to say that CD is congruent to CD. Of course, it's itself. We call that the reflexive property. So now we have that. What we don't have yet, at least written up, is that triangle 1 and triangle 2 are right angles. Now you should say that angle D is a right angle. ADC and BDC. This angle and this angle are right. And the reason is altitudes and altitude meets the opposite side at a right angle. Okay. And now we have the right angles. Now I can say triangle 1, triangle ADC is congruent to triangle BDC. And the reason is, that there is one thing wrong. I didn't say that. Let me put it down here. Triangle ADC and triangle BDC are right triangles. All triangles with a right angle are right triangles. Now, statement 5. So, of course, you should write statement 4 above statement 5. The two triangles are congruent. By hypotenuse leg is congruent to hypotenuse leg. Now, why did I have to say statement 4 that they're right triangles? And the reason's obvious, I hope. You can't talk about hypotenuses. You can't talk about hypotenuses unless they're a right triangle. Okay, so we had to get a right triangle. Okay, so now the triangles are congruent by statement 5. Now statement 6 nails it down. Angle 1 is congruent to angle 2, and we went over why. Corresponding parts of congruent triangles are in fact congruent. Okay, that completes that proof. Let's try another one. So again, these proofs, given no diagram, you have to be mathematically mature enough to draw the diagram and to write up what's being given and what needs to be proven. Somebody were to say that the altitude to the base of a triangle, an isosceles triangle, bisects the vertex angle. Well, you start off with an isosceles triangle and an altitude. And then you prove that that vertex angle, the one made from made using their altitude is in fact cut in half, bisected. Okay, let's try this one. Okay. If two angles of one triangle, are congruent to two pairs of another congruent, are congruent to two angles of a second or another triangle, then the third pair are congruent. Then their third pair of angles are congruent. So, basically we start with what they give us. They tell us we have two triangles, triangle 1, triangle 2. And they tell us if two angles of one triangle, say these two angles are congruent to two angles of a second triangle. Say that this angle is the same as angle 1 in the first one, and this angle here is the same as angle 2. Now they're saying that the third pair must also be equal. The answer is yeah, because the three angles must add up to 180. Angle 1 plus angle 2 plus, we'll call this angle here angle 3. This must add up to 180, and we'll call this angle 4 over here. In the second triangle, angle 1 plus angle 2 plus angle 4 must add up to 180. Well, in both cases, in both equations, we're starting with the same value. Angle 1 plus angle 2. Whatever that is. 50 degrees, 130 degrees. We're starting off with the same. You and I, we both have our bank account, and we have the same amount of money right now. And you make a deposit of an unknown amount, and I make a deposit of an unknown amount. And we meet afterwards, and we both tell one another what our balance is. It is $180. Well, if before we went into the bank, we had the same money, we both made the same two exact payments, and then today we both went in and we didn't agree upon how much we're going to put in, but you put in some and I put in some, and in the end we have the same amount of money. Well, of course we both put in the same amount. And how you would prove that is using subtraction. You would prove this by using subtraction. When you subtract the right-hand side, you get 0. When you subtract the left-hand side, well, angle 1 minus angle 1 is 0. Angle 2 minus angle 2 is 0. And what's left is angle 3 minus angle 4. Angle 3 minus angle 4. Just remember, these are numbers, and when you subtract them, the difference is 0. Well, they must be equal. When was the last time you subtracted two different numbers and got 0? 7 minus 7 is 0. 13 minus 13 is 0. 12 minus 12 is 0. But 14 minus 11 is not 0. These two have to be the same for the difference to be 0. So angle 3 must equal angle 4. If you don't like that argument, well, just add angle 4 to both sides. Angles 3 and angle 4 are equal. That is, yep, the third pair of angles are equal. there's the proof, actually. You don't need this over here, but there's the proof. I just recopied this up here only because I didn't have enough room. But the proof is right here. The proof is right there. Okay, that completes this interesting section. Do some more of these.